Okay, thank you, Paul. Now that you sort of understand the inputs for the finance model, I'm going to walk you through the inputs and outputs of the performance model. And the performance of your plant is characterized on 3 input pages, the climate page, the feedstock page, and the plant specs page. Paul discussed the inputs for the climate page, so I will start with the feedstock page. On the feedstock page, you will specify the solid fuel that you're using for your plant. There are 3 different ways to do that. At the top, we have an option to pull data from the NREL Biopower Atlas via web service. It's new. So you can simply input your collection radius and make sure that the correct location is specified on the climate page. Click Obtain Resource Data, and the web service will return the feedstock resource within the radius of the location that you selected. So you can apply this to your current case or not. If you click yes, these cells directly change to reflect the data that was taken from the NREL Biopower Atlas under the Resource Available category. You can see that the resources from the Biopower Atlas fall into 2 main categories, crop residues and wood residues, and then are further broken down into 8 categories. If you decide that it's not reasonable to collect 100% of the resource available within your radius, you can adjust the resource obtainability. You can see right now we are assuming that we'll be able to collect 20% of the biomass available in the region. You can adjust that as you'd like, and you can see that the total obtainable biomass resource and average higher heating value change to reflect that in real time. Also, something worth noting is that cells that appear with blue writing are calculated. You can't change these values. They're just displayed for your own information. And you can also adjust the baseline moisture content for these 8 types of biomass. The second option for specifying biomass is if you have access to a type of biomass that doesn't fall into one of those 8 categories, you can specify your own feedstock. The feedstock must be fully specified in order for the simulation to run. So here we need to supply how much of the resource is available, the moisture content, and then higher heating value and elemental composition. So you can see there's 2 ways to specify the higher heating value. If you know the higher heating value, it can be input in this cell, or it can be estimated empirically based on elemental composition. Maybe this is 5. So Sam can estimate the higher heating value for you. If you have no information about your feedstock, there are some really good online databases that have hundreds of feedstock characteristics, and they are linked at the bottom of the section here. And the third way to specify your feedstock is if you want to add a coal feedstock. You would use this in the case where you wanted to model biomass and coal-firing, or if you wanted to model just a coal-fired power plant, you would use a coal feedstock, which must be specified in a very similar way with the total resource available, higher heating value, and moisture content. And then this bottom section is simply just showing you the breakdown of your feedstock in terms of fraction biomass, fraction coal, and overall heating values, as well as estimates the total plant capacity with your selected feedstock based on the feedstock you have selected. So that is how you specify the feedstock of your plant. Next, I'm going to move on to the plant specifications page, which is next. Paul sort of mentioned that this biopower model is for conversion of a solid fuel to power via combustion. So the general steps are, first, the biomass is handled in some manner. It might include drying or size reduction before it's fed to a combustion system where under excess air will be burned and release heat, which is transferred in a boiler to steam, which runs the steam turbine to power generator. So first, the feedstock, this first section will determine to what extent your biomass is dried. The first option, fed as received, means that little or no drying occurs to the biomass before it's fed into the combustor. So it's basically just fed at whatever moisture content you specified in the feedstock page. The second option will allow for ambient drying. So this means that the biomass will reach an equilibrium with the ambient conditions before it's fed to the combustor. And the third option involves the installation of a dryer that will dry the moisture to this specified moisture, or dry the biomass to this moisture content before it's fed into the combustor. So then we move on to the combustion system. You can see down here in this box, estimated efficiency losses shows you the breakdown of where you're losing efficiency points in your boiler. So, for example, and these are calculated values, so they'll change in real time to reflect any changes you make in the inputs. For example, if you choose a fluidized bed combustor, the unburned fuel efficiency loss will change to reflect the properties of that boiler. You can change things like the steam grade, percent excess fed air, number of boilers, temperature, flue gas temperature, and boiler over design. So you can also see if you, say, increase the percent excess fed air, your dry flue gas losses will increase and your overall efficiency of the boiler will decrease. So after that's specified, we can move to the steam Rankine cycle or power block. This is where the steam powers the turbine. So you can specify the rated cycle conversion efficiency as well as minimum and maximum load. So it's important to note that this efficiency is separate from the boiler efficiency, so those are two different unit operations. You can also specify the power cycle design temperature, and this next table of inputs that you see are for adjusting the efficiency based on what fraction of the design capacity it's operating at, as well as how close the temperature of, or how close the ambient temperature is to the design temperature. So those are advanced inputs. If you want more information about that, you can see the SAM technical manual. But these are basically coefficients on a polynomial function to determine the efficiency based on part load, fraction, and temperature. And you can also specify whether the temperature correction mode will be dry or wet bulb, which correspond to either dry or wet cooling. And finally, or nope, we also have parasitics on this page, which represent the fraction of the nameplate capacity, or the percent of nameplate capacity that is required to keep the plant running. So that's adjusted, or it's specified just by a simple percent of the energy that you're producing. And finally, on this page, we have a time of dispatch schedule. So generally, biomass power and other solid fuel technologies are thought of as baseload power generators, but it's not always the case. And in SAM, we allow users to specify a time of use. So this means that the plant will be operating at some percent of its nameplate capacity during different hours of the day or times during the year. So that can be specified, as well as the ramp rate, which will determine how fast the power plant can reach its desired capacity. So those are the main performance model inputs. But before we run the simulation, we should specify a couple more things about the system, such as the capital costs, which are found on the Biopower system cost page. You can see the capital costs are broken down into direct and indirect capital costs, and further broken down indirect capital costs by major unit. So you can specify how much the unit will cost, also specify contingency, and then it will sum to the total direct capital cost. And indirect capital costs also includes things like engineering costs, construction, land, procurement, stuff like that, incorporates sales tax. And then when the direct and indirect capital costs are added together, we have the total installed cost displayed here, as well as the total installed cost per capacity. And also on this page, you can specify the operation and maintenance costs. And there's 3 different ways to do that. You can specify the cost annually, by capacity, or by generation. And anything you put in those cells will be summed to the total operation and maintenance costs. And you can additionally specify an escalation rate. The next important input page is the feedstock cost, where you can see the different kinds of biomass have been broken down, and their costs can be adjusted over here. You can also specify the delivery cost 2 different ways. So the first, distance fixed delivery cost, covers costs that you'll incur no matter how far the biomass travels. Might include something like a truck rental. And then the distance variable delivery cost is specified per ton mile, so that depends on how far the biomass will be transported. Might include something like fuel for the truck. So then the average cost is computed down here per dry ton, per wet ton or green ton, and also per unit energy. And you can also specify an escalation rate here if you expect that the biomass cost may rise over the lifetime of your plant. And you can also see it's the same structure for specifying the cost of any coal feedstock that you use down here. And finally, before we run the simulation, there's one more input page, which is the emissions comparison, which does not impact either the plant performance or the finances of your plant. This will simply compare industry average emissions release for average. So, for example, for whatever power source you're displacing, it will compare the estimated emissions of your plant to whatever you're displacing. So that, again, just uses industry average, and that's sort of just for your own information and doesn't affect anything in the cost or performance of the model at this time. So after that, your situation is fully specified, so you can run the simulation by pressing this green button on the bottom. And immediately you'll see that graphical data is displayed for both the financial and performance models. The first thing to notice would be the metric table at the lower left-hand corner, which displays the most basic and useful metrics for the plant. So it shows the annual energy you're generating, how much biomass you're using, capacity factor, heat rate, efficiency, levelized cost of energy, net present value, and payback period. And you can also see, immediately you'll also see the graphical data. The graphical data can either be exported, or you can even show the graph data in SAM itself if you want more information about where this came from. So you can see that you'll see in the cash flow graph, annual cash flow, monthly output, annual output, cost per watt, stacked levelized cost of energy. You can see this divides the cost of energy into 3 main categories: fuel expenses, operation and maintenance costs, capital expenses. So that might be useful if you're interested in the breakdown of the cost of energy. You can also view the results in tabular form. So first, you want to take a look at the cash flow sheet, which gives you detailed financial analysis in tabular form. So by year, breakdown of the finances can be exported in a couple different ways. Here are your options. And another feature in SAM is you can make a custom data table. So if you're interested in some monthly data, such as monthly heat rate, as well as the power block efficiency, you can compose your table as you want here and then export it to anywhere you find it useful using these buttons up here. And finally, a new feature in SAM is a time series viewer. So you can see sort of temporal variability in your variables using this time series viewer. Here, for example, is the hourly energy generated and how it fluctuates over time. You can zoom in on a specific month. You can display, let's see, 2 different sets of data at once. Zoom in and out. So that's a cool new feature. And other than that, I think Paul mentioned that you can create advanced sensitivity analyses, parametrics, but now that you sort of understand the basics of SAM Biopower and how to use SAM, I think we'll open it up for questions.
Great. Thanks, Jenny. I think if you've got a question, the operator asks that you type star. Is it *0?
*1 to ask your question, and to withdraw your question, press *2. Again, please press star, then 1 on your phone at this time to ask your question. One moment. Currently, no questions over the phone.
Okay, we'll give folks a chance to mull things over. I see a question in the chat window asking how to save results as an image. Let's see. I guess I'll take control here.
Over to you.
Yeah.
See if that works.
Okay, I think you should be able to see my screen now. So once you run, oh, Jenny, I think you retook control.
Okay.
So let me switch it back.
Got it?
Yeah, I think.
Okay.
Okay.
There we go.
So hopefully you can all see my screen, the SAM window. Jenny mentioned various ways to export the data from graphs and tables. You can also export images of the graphs just by right-clicking the graph. And then you can either copy the image to your clipboard and then paste it into a document, or you can export it as an image file. And there are various, you can choose bitmap, JPEG, or PNG. And that's true for most of the graphs. I'm just right-clicking the graph to open that shortcut menu. Another thing to mention about the results here is that these default graphs that appear when you choose graphs and charts here, you click the buttons at the bottom here to show the different graphs. If you can also create your own custom graph. So if you click Add New Graph or Edit, it opens this window where you can create your own graph. Press *1 if you have a question by voice, or feel free to type a question. For the advanced analysis options, we didn't explain how to get there. If you click this button here, Configure Simulations, then you can choose from a bunch of different advanced options.
Currently, there are no questions over the phone.
Thank you. Let me just show you a couple of the resources for getting help. The help system is context sensitive. So, for example, if I'm on the Feedstock page and I press the F1 key, I'm on a Windows machine, that opens the help topic for the Feedstock window. The help topics, basically describe the input variables. They don't have a lot of theoretical background. And you can see there's a help topic for each of the input pages. You can visit the SAM website and download the reference manual for the Biopower model. So this is the SAM website, and under Resources, there we go. There's a reference manuals link, and we have a Biopower reference manual available here, so you can download that as a PDF. And the reference manual is a detailed description of the theory of the model and the calculations behind the scenes. So if you want to understand the model, you can download the reference manual from the SAM website. I'll also take a moment to show you the support forum where you can post your questions. I don't know if anybody's asked anything about Biopower recently, but I can search for Biopower. And that's a list of all of the pages on the website that have the keyword Biopower. You've got the website, the help system, and the reference manual for if you need help with the model. On the support forum, we try to turn the questions around within 24 hours. It may take a little longer depending on what's going on. Jenny, was there anything else you wanted to mention about the model?
I think we have most of it covered.
Okay.
I guess I didn't go over the output for the emissions comparison graph.
Okay. You want to?
Sure, I'll take control back. As I mentioned, it compares industry average emissions with estimated emissions from your power plant that you're modeling. So you can see you've broken it down into ash, which isn't an emission, it's more like a byproduct, NOx, SO2, and CO2. A more robust emissions calculation will hopefully be on the way in a later version of SAM, but for now this is just a way for you to see that by switching to Biopower you can emit 80% less SO2 than a conventional mix of fossil fuels. And yeah, I think that's the only other thing I wanted to show.
Jenny, could you just switch over to the climate page, please?
Sure.
One thing sort of about the mechanics that's a little tricky is when you choose a file here on the climate page, SAM reads a latitude and longitude from the weather file that it displays over here under location information. Then when you go to the Feedstock page to download your resource data, SAM takes that latitude and longitude data from the climate page, and then so that resource data that you just saw is for the latitude and longitude on the climate page. Okay.
Currently, there is a question that is coming over the phone. Richard Caputo, your line is open.
Okay, thank you. You were comparing it to the pollution emitted to a weighted average of, I guess, all national power systems?
Yes.
How do you pick other choices like a certain kind of coal plant or a combined cycle gas plant? How do you do other kinds of comparisons?
Well, currently, the only options for comparison are the ones displayed here. So coal is divided up currently into lignite and then non-lignite coal. You can see on this page, so this is power derived from natural gas. So this could be, just whatever the national mix is of natural gas technology or generation technologies. You could, if you go to the results page in the data tables, there will be single values. You can look at the NOx produced in tons per year. So if you could use that to compare to some value that you have better knowledge of in terms of how much NOx you might produce from, you said, a natural gas plant, you can compare that number directly. But the graph just compares to the industry average. But there is a way to extract the actual what you're emitting in tons per year through this in the output under data tables, output variables, and then single values. They should all be in here.
Okay. Thank you.
Yep.
At this time, there are no further questions over the phone.
I guess I could. Did you have something else, Jenny?
Nope.
Okay. Could you show the system summary page?
Sure.
So this is kind of a point of confusion sometimes with SAM. This system summary page shows values from other pages. If you're on a Windows machine, you'll see these numbers highlighted in blue. These input values are not editable. So the nameplate capacity came from the plant specs page, for example. The total direct cost came from the cost page. This is just intended to be sort of a place to get a quick snapshot of your system, but you can't change any of these values. So once you get used to using SAM, you probably will mostly ignore this system summary page. But oftentimes when people are first using it, they expect to be able to change the nameplate capacity here, for example. So just be aware that those are values extracted from other pages in the user interface. I think we have about 10 more minutes scheduled for the session. So if you have any questions, feel free to speak up.
Again, any question over the phone, press star then 1. Currently no questions over the phone.
Jenny, do you know anything about future development plans for the Biopower model in SAM? Are there anything going?
Well, so like I mentioned, we're working right now on better life cycle data. So the emissions comparison will actually be more of like a life cycle analysis for the Biopower plant. We also are trying to implement gasification power. Like Paul mentioned, SAM is mostly for power generating technologies, so certain things like integrated gasification technologies currently won't be able to be in SAM, but we will be able to use gasification to power technologies, hopefully, in the next update.
Okay, I think we can give folks another couple of minutes in case there are questions. After a couple of minutes, we could probably sign off.
Currently no questions over the phone.
Okay, then I think we'll sign off. Thank you for your participation. If you have questions about the model, please feel free to contact us on the support forum, and either I or someone else on the SAM team will respond. and that's it for today.
Thank you for participating. Today's call has concluded. Please disconnect at this time.